On this channel, we provide useful programming information with practical code examples. This time, we will cover the map object. We will explain step by step, from basic operations to practical examples that are useful in real-world scenarios. Enabling subtitles will make the code descriptions easier to understand. Map is a collection that stores key-value pairs. It is similar to an object, but differs in that any type, such as objects, functions, or primitives, can be used as keys, and the insertion order is preserved. First, let's look at how to create a map and perform basic operations. The following code is a minimal example that creates an empty map, adds keys, and retrieves values. In this code, you can add elements with set, retrieve values with get, and check the number of elements with size. Map maintains insertion order, making it suitable for order-dependent processing. Here are examples of typical read, write, existence check, and delete operations. With the following code, you can check the return values and effects of each method. Get returns undefined if the key does not exist. Has checks for the existence of a key, and delete removes a key. Also, since set returns the map itself, method chaining is possible. One of the main advantages of map is that you can use objects directly as keys. The following example shows how to associate values in a map using objects as keys. When using objects as keys, it is important that they are the same reference. Even if their contents are the same, objects with different references are treated as different and are not the same key. Map preserves insertion order, so iteration is often used. Below, we show how to use for each, and the keys, values, and entries methods. Entries returns an array of key, value, pairs, which can be turned into an array using the spread syntax. Note that the callback for each receives arguments in the order value, key. You can convert an existing object to a map, or convert a map to a plain object or array. Using object entries and object from entries makes conversion easy. However, since object keys are limited to strings or symbols, non-string keys are lost when converting back to an object. When counting the frequency of elements in an array, using a map makes the process simpler. The following code is an example of using a map to count the frequencies of strings in an array and sort them. Using a map allows for easy existence checks and updates. This can be done with objects as well, but map can be more intuitive when working with arbitrary keys. JSON.stringify cannot serialize a map directly. If you need to save a map, you must convert it first. The following example shows how to convert a map to an array before turning it into JSON, and how to restore it. Maps that need to be saved or transmitted should be converted to arrays before serialization. When restoring, use JSON parse to convert into an array, then turn it back into a map. WeakMap differs in that its keys are weakly referenced, subject to garbage collection. It is useful for holding cache or metadata with objects as keys, automatically releasing them when the key object is collected. WeakMap cannot be enumerated or have its size checked, but is useful for preventing memory leaks. Map is a convenient collection that, unlike objects, allows any type as key and preserves insertion order. By understanding everything from basic operations to advanced usage, you can manage data more flexibly and intuitively. By using object and map appropriately according to the use case, you can greatly improve code clarity and readability. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. I hope this video helps improve your programming life. By subscribing to the channel, we can deliver more useful information to you.